So first of all, thanks for the invitation here. Dean and Chris, Ryan, Lana. I was joking when I came here and saw all of this. I was like, I can't give a talk because I was literally speechless by this place. Absolutely awesome venue, and happy to be here today with you. I'm going to introduce the company to you and our products. I will talk a little bit about the technology. I will also talk about the safety aspect of hydrogen. It's a topic that always comes up, and I think there's maybe some misperceptions there. So happy to talk about that. And then I'll also introduce what our energy brand Hyla is doing, and specifically here in this area. We've opened some fueling stations, so I'm going to go into that as well. And then I'm going to try and be brief with the presentation because I think it's way more fun if we have a discussion and if you have some questions here. So happy to answer all of your questions afterwards. So I will start with a little movie, a little clip, just to describe what we're about at Nikola and why we're doing what we're doing. And I'll have some numbers around that too, but I think that little clip describes really well what a lot of us at Nikola think and why we have so much passion for this.
Sometimes I feel like we're just one company, what impact can we really have? Climate change is happening on a global scale. On average, each Class 8 truck produces far more emissions than a passenger vehicle.
This business is maybe slow when it comes to technology adoption. There hasn't been much change over the last 50 years or so. But changing the world has never been easy.
Converting our use of energy from fossil fuel over to hydrogen, and this is where the future lies.
We're striving to make a change to a 100-year-old industry. It's ripe for disruption.
The challenges that we're up against are massive. We're trying to decarbonize an entire industry. It's not just one vehicle, it's the future.
It is for a greater good.
The whole point of technology is to make humanity better. What we're doing right now is it's proving, hey, this is possible.
It's so easy to just sit down and do nothing. What's not easy is to try to make a difference.
There is a sense of optimism because we are doing incredible things.
It takes real fortitude and strength to forge a path that nobody has ever attempted to. You just gotta keep moving forward. That's what makes this world go round.
Pioneering to eventually get to a zero emissions world, it's not that fun, but someone has to do it. And why not me? Why not us? Why not collectively as a people recognize that we can do better? And it starts with taking action.
So I hope you saw a couple of familiar places in this clip. You also saw some of our production line in Coolidge, Arizona. So we're headquartered in Arizona, Phoenix, Arizona. You can see a picture here of our headquarters in the background. And then we have our manufacturing facility in Coolidge, Arizona, which is about an hour south of Phoenix. And that's actually a big advantage. I think everyone that has worked in this space and manufacturing knows that it's always good to go and see, right? Genji Gonbutsu, as some of our Japanese colleagues say. I probably mispronounced that, but it's important to be able to get the engineers to the plant, to see what's happening, to see what the issues are, and that's been really an advantage for us. We've been founded in 2015, originally in Salt Lake City, Utah, before we then moved to Arizona in 2018. And we have about 1,000 employees at this point, between manufacturing, engineering, and all of the corporate functions. So we're doing trucks, obviously, and you saw one of our trucks outside. But the other part that we're involved in is the energy infrastructure. So I think we can all look back on kind of the electric vehicle revolution and how important it was to build out the infrastructure with the cars. And we have a same approach here for the hydrogen trucks specifically. We understand, and also looking back to some of the efforts in the past, we understood that we have to do both. We can't just focus on the truck as a product, but we also have to bring infrastructure solutions with it and really scale it both at the same time. And for that reason, we introduced a separate brand called Hyla. And that team is taking care of working with an environment, an ecosystem of partners to bring these solutions to the market. And I'll go into that a little later. So why trucks? Why are we doing what we're doing? You saw and heard some numbers already in the little clip, but it's really about the lever you have for the decarbonization efforts. And if you look at it, one truck pretty much is equal to 23 cars. Each diesel truck, on average, by average numbers of the EPA, produces 106 metric tons per year of CO2. 106 metric tons. That's a large number. And so you only need a couple of trucks, a few thousand of trucks, to really make a big impact here. And once you go into the ports, specifically, right? And look at a port like the Port of Long Beach in LA, it even gets worse because you have all of the idle happening there with the diesel trucks, and it's one of the, it's one of the places with the worst air quality, and not only in the ports, and not only for the drivers and all the workers in the ports, but all of the communities around that. And that's why it's so important that we tackle this problem right there. And that's one of the big reasons we're starting our efforts specifically in these applications and locations. So far we've collected about 3.7 million miles. That's getting more every day. So this number is, I think, 2 days old. So it's probably by now more like 3.8 or so between our fuel cell electric and our battery electric truck. And that equates to over 5,000, almost 6,000 metric tons of CO2 in savings. And it also shows you that these trucks are out and running. We're lucky enough that one of our great partners and fleet customers, IMC, brought a truck here today. So that's the truck out there. And they literally pulled that from service. So that truck is running in 1 or 2 shifts even every day, right? And they cleaned it up for us nicely and brought it here so you can all see it. But these trucks are being put to use. They're not just standing around, but they're really being driven, and that's what it's about. Trucks are a tool to generate revenue for our fleet customers, and so these trucks need to run. They can't be down, the fueling can't be down, so there's a big challenge for sure, compared maybe to passenger cars. It's increasingly important to get these trucks really in high utilization. I'm going to talk a little bit about Coolidge here, which is our manufacturing facility. And if you look to the left here, bottom left, it used to be just a brownfield pretty much, just open desert. And we broke ground there in 2020, I believe. And about 12 months later, we moved in and we started our first prototype builds and then ultimately production there. The BEV has been in production since 2022, and we started the fuel cell production mid of last year. We have about close to 700,000 square feet of facility space there with warehouse, production line, prototype shop. We also have an engineering operation there, and we have certain testing facilities there. We have a small test track as well as a full Class A dyno facility. And we can, with the line as it's configured today, produce up to 2,400 trucks. That's in 3 shifts, so every shift about 800 trucks. That's the line capacity we have. And then we obviously have plans to build that out even further. One of the tools that we've been using from the beginning, and that's critical as we scale up, is how we configure the production line. You see the AGVs here. And with that, we are able to just scale the line with our business. So when we initially started BEV production, we had the line configured in a certain way, and once we introduced the fuel cell product and we scaled production, we reconfigured the whole line. And using those AGVs, those automated guided vehicles, this was much easier than in some more traditional production line setups. So About the trucks, we're really working on one platform here. So it's all about zero emission, it's about one platform and two applications, two powertrains. One battery electric, one fuel cell electric. These trucks as a platform share a lot of the components, share a lot of the software. If you think about the whole back-end system, the connectivity, the framework for over-the-air updates, all of this is shared between both of these trucks. But there's differences, and they're used in different applications. The fuel cell truck has a range of up to 500 miles, battery truck up to 330 miles. But when you look at the powertrain, the e-axle itself, that's a component that is shared. Even though this component is shared, we have rated it slightly differently in those two applications, and that just has to do with the overall system layout. So in the fuel cell truck, the power output is 400 kilowatt continuous, or 536 horsepower, and in the battery electric truck, 480 kilowatts, 645 horsepower. The battery size for the 330 mile range here for the battery truck is 738 kilowatt hours. And we're using the same pack at this point, and we're using 9 packs in the battery truck, so 9 times 82 kilowatt hours. And then 2 of those packs in the fuel cell truck for a total of 164 kilowatt hours. The difference really is the refueling or the recharging time. So the battery truck, we're charging with up to 350 kilowatt. In the future, we'll obviously work on increasing that charge power, but that comes with implications on the charging infrastructure in the grid. So also not trivial, right? And with the 350 kilowatt charging, we're looking at a charge time of about 90 minutes for a typical, 10 to 90 charge. But that's where the fuel cell truck has really an advantage, especially as you look into 2-shift applications, because we can refuel this truck in less than 20 minutes. Again, you can ask our colleague here from IMC about his experience, but pretty much it works like you're running a diesel truck. So you pull in, you don't need to drop your trailer to get into a charging stall. You just pull in with your trailer, you stop at the fueler, you get hooked up, you get refueled in maybe 15, 20 minutes, and you are out the yard again and you continue with your shift. And that's good for 500 miles, as I mentioned, always depending on the application. As we look a little deeper into the layout and the system design of the fuel cell truck, we have a cap-over architecture that was partially driven by our collaboration in the early days with Iveco, European truck OEM. And pretty much all of the trucks in Europe are a cap-over design that has to do with the length limitations over there. We packaged a fuel cell system in the front underneath the cab, where you would typically find a diesel engine in these kind of trucks. And then we have the battery packs in the center of the frame. And then we have a system of 5 hydrogen tanks. Those are Type 4 pressure vessels. Each of them holds 14 kilograms usable hydrogen for a total of 70 kilograms usable. There's 3 in the back, what we call the backpack assembly, behind the cab. And then we have 1 tank on each of the saddle locations, so a total of 5. And then I mentioned the e-axle. That's something that's shared between both applications, the battery truck and the fuel cell truck. And that's currently packaged in a 6x2 architecture, meaning we have 1 driven rear axle. It's also something in the future we'll obviously look into a 6x4 application too. The point I want to make here is it really comes down to system design, system optimization, and a lot of software. And especially talking to students, I think this is something we cannot underestimate, the power of system level, overall system level optimization and how things play together. If you think about durability aspects of the fuel cell and the battery, it really comes down to how do you operate those systems together? How do you distribute power? What's your energy management, right? Down to how do you actuate your paddle and so on. So there's a lot of optimization you can do first in the system design itself. Think about the thermal system, right? We actually combine certain loops and we're using certain components in dual function, like a brake resistor, both for brake resistor functionality and a heating element, for example, right? We use waste heat that's produced in a certain area of the truck to maybe heat up the cabin, right? And so there's a lot there that can be done in optimization. And the same goes for the battery truck, even though that architecture is arguably a little bit simpler. We don't have 2 different power sources. We don't have media like hydrogen that we carry. We don't take oxygen out of the air and so on. So in that sense, it's a little simpler. You see the layout here with 9 packs. Those are parallel packs, which also means that if for whatever reason there's a defect in a pack, we can actually continue to run almost at full power. Obviously not full energy and range, but close to full power. And in the BEV truck, we don't have the fuel cell system, so we use that location to package a lot of the different high voltage auxiliary components and so on. So I mentioned I will talk about hydrogen safety, but before I do so, just want to talk a little bit about the safety of the truck itself. Obviously, we have driver assistance systems, and some of the most important ones there are things like lane departure warning, and most importantly, advanced emergency braking systems. We have front and rear cameras, and those functionalities go for both trucks. And then on the fuel cell truck, we also have blind spot detection on both sides. And it's actually a system with 2 radars to ensure that you have full coverage along the whole side of the trailer as well. We developed our own adaptive cruise control as well. And we have other warning systems that we continue to improve. All of these things, just like the other vehicle level software and supplier components, we can update over the air. So we implemented all of our back-end systems. We implemented our own central gateway solution, connectivity unit, so we can be able to go into the truck and update all of those ECUs. Thank you. And that gives us also an advantage when you think about service, because this truck is so connected. We actually developed our in-vehicle diagnostics as well. So you don't need a diagnostics tool to hook up. So you don't need to go into a shop, hook up the tool, and then read your fault codes, run your routines. You can access that right inside of the truck. You obviously need the access rights. There's a technician level pin that you will need to access that. And we can then also monitor that out if you are in a shop and let's say the vehicle is up in the air. Obviously you can also access that remotely with a laptop. And then we also bring that to a fleet monitoring system. So now the fleets can monitor all of their assets. They can see where are the trucks at, what are they doing, do they have any kind of fault codes, do we need to take care of them, what is the fuel amount, and we can start even setting parameters specifically for the trucks or by driver or by asset. So the different tools that we have in the area of digital products ranges from some of the ones that I mentioned already with Nikola Fleet and some of the back-end systems for our service departments like Nikola View and Pulse. But we also have the Nikola Drive app, which is an application on your phone to then access the truck, turn it on, precondition it. It also acts as a key, right? So maybe pretty typical at this point for cars. I would say not as typical yet for trucks, but it's all part of our ecosystem. And then last but not least, the actual interface in the truck. So our instrument cluster, our main HMI display, touchscreen, that's all connected and all implemented in-house. And here you can see a nice picture of that. So instrument cluster, the HMI, and the main HMI display here is where you would access for example, those diagnostics information, and you can run those routines right there from the truck. So, okay. And here you can just see a picture of the app itself. So you can access different assets. For example, for me, I have access to most of the development fleet, all of the trucks that we have in our headquarters at Coolidge. So I have all of these units, and then I can pretty much log in and I can open the trucks or air condition it or other features like a beacon and so on. We also have this little feature here, which is quite nice, which is the pre-trip. So I'm not sure how experienced you are with driving trucks, but you have to do a pre-trip every time before you start a trip with the truck, and then also post-trip. And with this, we actually support you doing this by activating different lights as you go around, and you can check where you might have needed, a second person, or you have to go in and out of the truck to do that. So just little features like that, where we're really trying to make the life of the driver easier. And I would say that has been overall kind of the other priority next to providing zero emission solutions, was make the truck a better work environment, a better workplace for the drivers. Their jobs is hard enough, especially operating in the ports, and every bit we can do to make it a more pleasant environment for them, not having all of the noise pollution the whole time from the engine, the shake and rattle from the engine, the fumes from the diesel, a better HMI overall concept for actually using the truck. All of that is important as you think about the driver. And we actually just had Driver Appreciation Week last week. So I think at that point, shout out to all the drivers that are out there every day and, transporting pretty much everything you touch, all the goods you buy is on a truck at one point. And so we got to take care of the drivers. Now let's talk about safety. And as we think of safety at Nikola, we want to look at this as kind of the layers of safety, or the onion of safety, right? We obviously have regulatory requirements, and those are mandatory, so no questions asked. Then we have industry standards, SAE standards, ISO standards, and so on, that we also all utilize in the development of our trucks. But then we have, on top of that, our own safety requirements. And a good example is we established our own crash safety standard, because there isn't really much in the US about trucks. There is quite some regulation in Europe. And so based on all of that and other industry standards, we developed our own crash testing standard for these products. And now every product we develop goes through that. We also implement, for example, a crash detection system that utilizes the same technology as an airbag system. So within 200, 300 milliseconds, we detect the crash. We know, is it a severe crash or not? And we can take appropriate action in the truck to mitigate the effects of the crash, which could be firing pyro fuses to get rid of the high voltage in the truck, could be closing the tanks, shutting down the system, or it could be nothing if it's only a very light bump, right? And so, we're involved in a lot of the industry groups, right? We have been part of the Center for Hydrogen Safety and the Hydrogen Safety Panel pretty much from the beginning, members in our team. And we continue to provide feedback for certain incidents that happen outside. We exchange best practices there as well. And we also organize and help organize seminars. We do outreach to certain first responders in the communities where we're active. So all of that is part of it and very, very important, because hydrogen might be new to them. And so we need to, as an industry, collectively make sure that we have good training programs, that we kind of exchange on certain incidents that happen, exchange best practices. And that's something that we've really been engaged from the beginning. Now, this is a list of different codes, standards, regulations, and our involvement has been pretty much involved in most all of these standards here as it relates to hydrogen. Obviously, there's a whole nother list as well for high voltage that's equally important. I think at this point that's just more known, but obviously the same goes for high voltage safety, electrical safety. And if you look at the vehicle level, so safety ranges pretty much from component level, system level to vehicle level, and I'll have some examples of videos specifically for the component levels as well. But if you look at the truck level itself, I mentioned a crash detection system, but we're also doing hydrogen detection. So we have a concept on where we deploy hydrogen sensors throughout the vehicle, which is at locations where a leak could occur, for example, where you have a joint. And then we also did an analysis and assessment, where could hydrogen accumulate, and that's pretty much where we place the sensors. And then we monitor this continuously, and we set limits that are even more conservative than in the GTR 13 on these detection warnings, as well as when we essentially start shutting down the system as soon as we detect leaks that are 3% hydrogen or more. And then obviously part of that is communicating with the driver. Yeah? So giving the driver the information, a warning light, a telltale, but also not only a telltale that could be cryptic, but actually we have a message center that then tells the driver what's happening and what they should do. For example, at a yellow warning, they would say, okay, we have a warning here for hydrogen detection, please go to a service location. Now these are the videos, and I think it's always good to show those because it just shows on how we test these components. And what you see is here two tests. One is the one in the top, is a pressurized cylinder, a hydrogen pressure vessel. And that's essentially engulfing fire. And what we're testing is the TPRDs, so the thermally activated pressure relief valves. And if you look at that little chimney here, that's how it's connected to, and you'll see that at one point it triggers, and what it does is it releases the hydrogen. And that's not a system that's based on any electronics or something, it's a thermally activated relief valve. And in these situations, we get rid of the hydrogen. So we have vent lines in the vehicle that mostly point upwards, and so you can actually get rid of the energy. And that can make it potentially safer than a diesel truck or a battery truck because you're stuck with the energy. Whether it's battery, whether it's the diesel, it's gonna be around your vehicle, right? Hydrogen is lighter than air, and we trigger a release of this actively, and at that point can just vent the hydrogen, won't do any harm. And even if that flame, that release here would ignite, it would be pretty much a controlled burning of hydrogen. And so that's where I come back and say hydrogen can be very, very safe. Obviously, we need to design the systems to be safe, but if you handle it the right way, it can be a very safe fuel for these applications. The lower test is a ballistic testing, so we essentially shoot on the tank and we had to do it a few times because we couldn't penetrate in the first 2 shots, I think. And what that test is for is to prove that you're not bursting. So if something penetrates the tank, it's okay to have it vent again from that location, but what it can never do is burst. So you never want the tank to burst, and you never want the tank to leave the vehicle. So pretty much with all the testing that we're doing and crash testing, those are the main criteria. If you can get rid of the hydrogen, that's fine. And that's another engulfing fire test, and I showed you the one with the TPRDs, but another thing that we developed as the first ones and actually brought to production with those tanks, with our tank supplier, is a thermal protective coating. And with that, we actually can withstand engulfing fire much longer than any other tank could. And we're talking about a resistance of pretty much 1,000 degrees Celsius, and we can withstand that over 30 minutes. So by that time, we can absolutely ensure that the TPRDs have activated and that we have vented all of the hydrogen. This is another example of the crash testing that I already mentioned. So we're obviously testing this to the locations that are critical. So in this case, you see a side crash right into the pressure vessel here. We designed a deformable bracket that can pretty much take the energy of the crash event. So again, it's different layers, right? It's the mechanical design, the fundamental design, it's the detection capabilities and its reaction capabilities. This crash test we repeated, by the way, without that structure on the side, and we directly crashed into the vessel as well. And we monitored it for, I think, 2 hours after the crash, had no leak. So last but not least, and then I hope we have a lot of questions here and a good discussion. I'm going to talk about Hyla, our energy brand. So how do we go about building the infrastructure system? Key have been those modular units. So if you think about creating the demand and kind of pushing the whole ecosystem, you got to find customers, right? We develop a product, we have a truck, now we have to find customers. We need to understand where do they want to operate, and then we have to build that demand and the density. And those modular fueling units, those are pretty much fuelers on wheels that we can then bring to different locations. There's still some permitting involved, but not as much as with a permanent station. A permanent station can take you 12 to 18 months of permitting, and then you have to build it out and test it. These modular units, they might only take, let's say, 8 weeks or 8 to 12 weeks or so of permitting, and then you can bring them and relatively easily install them somewhere. It takes you about a day to set up, and then we can start fueling. And then those modular units, they can support 20 trucks or so each, and we can deploy multiple of them in a given location. And that way we can really start building the density and building the demand. And now it will be much easier to say, hey, I'm already running fleets of maybe 50 trucks here in this area. Let's do the investment of a permanent station, either we or together with a partner. And those modular assets, they can store about 1,000, depending on which brand, but they can store around 1,000 kilograms of liquid hydrogen. So that's good to, as I said, fuel about 20 trucks or so. So if you look at the roadmap, what have we done already? So our activities are very much focused to California at the moment, and a lot though in Southern California, right here. We also have some activities up in Canada because they're very supportive in terms of the infrastructure as well as incentives to purchase the truck. And that's also one of the main reasons why California. It's the ports, as we talked about, but there's also massive support. If you think about incentives available, and we have Naui here, who's our expert for this. California, the state, gives you up to, or actually a minimum of 240,000 purchase incentive for the fuel cell truck, 120,000 for a BEV truck under the HVIP program. And then there's actually additional incentives available depending on the size of your fleet. Depending on what specific location you operate, there's more on county level available as well. So we started building out the first stations here, very close by. First one was Ontario, then Long Beach, Santa Fe Springs, and we have planned additional stations. You can see here Wilmington and so on. We're also working with an ecosystem of partners. You can see Shell Ontario here, where we have an agreement. We have an agreement in Northern California with First Element Fuel. They build up a brand new, very modern truck, heavy-duty station, and we have an agreement with them as well to fuel our fleet there. And then what we're planning to do is we're planning to connect. So we're building out hubs, and we'll do that in other states too. And the next step will be to connect those hubs. So we'll establish stations in between. So we're going from maybe out and back applications more to A to B applications. And that's really our strategy here. We start with those hubs, we develop a hydrogen highway, and then we rinse and repeat, right? Then we can go the next major freight corridor and so on. We can start branching, towards Arizona, obviously. Where you can see our Coolidge facility where we have a fueling point too, and then go further east towards Texas. So with that, I'm going to conclude my little talk here. I hope it was interesting for you, and I'm happy to take any questions now. Thank you. I think you were.
I'll start with a basic analogy question for us laymen. So at the beginning, when you're presenting the argument, and you say that tailpipe emissions from one of your trucks is equivalent to 23 passenger cars, how does one? That's a great analogy, very easy to. I know what 23 passenger cars looks like. When someone brings up, and I've heard this obviously for decades, a cubic metric ton of CO2. What does that? How much is that? What does that look like? How does that relate to the real world?
A cubic metric ton.
Right, yeah, 5,000 metric tons of CO2. Sorry.
Yeah.
What does 1 ton of CO2? What does 1 metric ton of CO2?
Oh, okay. Yeah.
Sorry.
So I mentioned the 106. Metric tons of CO2. So metric ton, 1,000 kilograms of CO2 emitted per year. So as you look at the 3.7 million, right? that equates to the short of, what was it, 6,000 metric tons. I'm not sure if that's addressing the question, or was it related back to passenger cars, or?
No, just a general analogy. Don't worry about
Okay.
it. It's mostly irrelevant.
In the back?
Here was a question.
Oh, yeah. Now, as far as service centers, what currently do you have, and then what's obviously the main plan 5 years from now, say we say?
Good question. About service centers, we work with a dealer network, so we have established multiple dealer relationships and collaborations. One of them here close by is Tom's Truck Center that we're working with. So we have a bunch established all across the country. We have a few in California, but then also other states. So we're working with existing dealerships, essentially existing rooftops that may or may not do Class A trucks, or maybe other applications or classes of commercial vehicles today. And then what we're doing is we're essentially training them. So we have our own service team. So as we come in and, for example, develop a new dealer, develop a new network or area, we come in with our service team and with our tools, and then we essentially start training our dealer partner to then take over more and more of the service work. But that's important in Class 8, I think, as well, that you have those dealer and service points and locations. So we're not doing this all in-house, but we're working with partnerships with existing dealers.
So I see more of a, not necessarily a hardware, like the structural part of the vehicle itself. I'm thinking more like a software thing. Is that where you see future problems?
Challenges.
It seems like it's got a lot of software.
Yeah, it does. I think so first of all, for sure you need to do a lot of testing on the software itself, but then also as you integrate it into systems and the vehicle itself, because where there's a lot of software, there's potential for a lot of bugs. I think the advantage that we have is that we control a lot of this ourselves. So we're not relying on suppliers to do our vehicle level software, or doing a lot of offshoring or anything. We do this all in-house. So we have our software engineers right there with us in either headquarters or Coolidge. And so if there's an issue, we can bring them in and we can start actually addressing those issues. So our turnaround time to address any of these issues or bugs can be much, much quicker than maybe an OEM that's relying a lot on outsourcing with other suppliers. Having said that, it's definitely continuous improvement, but I think there's the potential is that we're able to do quick turnarounds and we can over-the-air update most of the software.
To answer the previous question.
Oh, okay. Yeah, you can pull that up if the question is by volume. Yeah. How many shipping containers?
852.
One truck?
Yeah.
852 shipping containers in volume. If you're not asking about the tons, the weight, but by volume, yeah, 852 shipping containers apparently.
Each truck, each diesel truck.
Thank you.
So as a manufacturer, you have access to all the vehicles that leave the facility, correct?
We have access
So
to
you can constantly monitor, so you
Correct.
can see if something's...
Correct. We can essentially see if there's any fault codes. We can essentially remote diagnose it, and we can even run, certain routines remotely through that.
Cool.
And I mean, to be honest, there were, initially, obviously, when we started developing and testing these trucks in-house, there was a lot of software issues that we had. But it's really, the key is to detect it quickly and then to be able to implement fixes quickly.
On the hydrogen range, the truck range, and full, California weight regulated, is the range actually up to 500 miles now?
So it always depends on the application you really run. So a I like to always talk in examples there. So I have my CDL as well, so I test drive these trucks as much as I can. And I took one of these trucks fully loaded, 82,000 pounds, from Phoenix, actually from Coolidge, up to Flagstaff, which is a pretty severe route. Goes up to 6-7% grades, pretty steep climb, and high speed limits, 75 miles per hour. Believe it or not, trucks could theoretically drive that from the regulation point of view. And I did that fully loaded, the round trip, and I got, the trip is about 40 miles or so. And I made that with a little range remaining, so about a 450-mile range on that application. If you look into the ports, we have some people here that run, if you're not running maybe fully loaded, you have a speed limit of 55 in California for trucks. We've seen some people getting ranges of 550, 600 miles even. So I think 500 is a good number to talk about your average, range. And in fact, if I take the average fuel consumption, fuel economy, of all the trucks that are running with our customers, it sits right around 7.2 miles per kilogram, which is what we designed it for. That was our target, and that equates exactly to 500 miles of range. So that's what we're seeing as an average in the field with our customers.
Thank you. What's the cost of a tank?
So I'm going to answer that real quick, and then we go to the next question. Cost of a tank full, so 70 kilograms. I can't give you a number because that's very specific to our fleet agreement. So as we sell those trucks, we're also doing fuel purchase agreements with the individual fleets. So it's an individual negotiation depending where do you run, how many trucks do you buy. Honestly, no different than how the diesel truck market works. Whether you purchase the truck or whether you have a fuel purchase agreement, it's very fleet individual. Obviously, our target is to get with both the truck and the fuel towards diesel parity, because total cost of ownership is everything in this market. So that's what we're aspiring to go to. We're a little away from on the truck side. That's why these incentives are great, obviously, to make this work for us and our customers. And we also have some ways to go on the hydrogen. But I'm going to tell you, it's much less than what you would see at the pump as a price if you try to fill up your Mirai or something. So. Sorry.
I have a two-part question. First question is statements. You've been talking about the lack of carbon footprint, which is absolutely fantastic. What is the power source, number one, that you use to create the hydrogen? And the second question is, have you done a study what the carbon footprint is, batteries versus your hydrogen tanks?
Excellent question. Kind of goes into well to wheel, cradle to grave kind of analysis. The hydrogen at the moment, most of the hydrogen you can buy in the US is not green hydrogen. And with green hydrogen, we typically describe low carbon intensity hydrogen that is, for example, produced by electrolyzers with renewable energy, renewable power sources. We're working with partners to get more green hydrogen production established. And there's some, projects that are coming online in the next couple of years. But until then, we have to also utilize other sources for production. So we obviously have SMR as one production method. You can do carbon capture, which then is often referred to blue hydrogen. So what we're really looking at is carbon intensity of the fuel. And we're putting in a strategy to get that as low as possible going forward. But we have to start somewhere. So even with what you can source today, your overall equation still works in favor with the hydrogen. And then for the battery electric truck, again, it comes back to how do you source your power, right? Where do these fleets run? Do they have certain power purchase agreements in terms of specifically purchasing renewable power or not, right? So it really comes back to where do you run. Also there, if you take your average mix right now, in California, you're still at an advantage with the average as compared to diesel. Now the next step is that's kind of the fueling side of things. The other one is production, right? Producing batteries, producing tanks. That's where it gets even more complex, and then also correlating it back. So I would not want to make a generic statement there. We are looking in these analyses. We're looking for every part we source. We pretty much look at the carbon footprint there. And we're pushing our suppliers to lower that as much as possible. That goes also for transport, for example, right? Ideally, we don't want our parts to be transported by a diesel truck, right? So we're actively pushing all of these areas to essentially lower the footprint. Out the gate, it's not going to be possible, right? We have to start somewhere.
It just seems logical to me when that truck rolls out of the plant, you're going to have a lower carbon footprint on the hydrogen side than you would a battery side.
Yeah, I would tentatively, I would say, or directionally, I would say a battery truck is probably worse than a diesel truck, and a hydrogen truck is maybe to a similar level.
I have a very good reason to push the hydrogen.
Oh, sorry. This, I think.
Hydrogen fuel storage, did you say whether it's stored in a gaseous form or liquid? I think you mentioned the full filling station.
Yeah. I think I have not specifically mentioned that. I mentioned the type of cylinders we're using are those type 4 carbon fiber tanks with a plastic liner, and that's where we store hydrogen in gaseous form at 700 bar, 10,000 psi. So when it comes from those fueling stations, the storage there is in liquid form, and then we essentially fuel it into the truck in gaseous form. I think first here and then.
So you guys did a great job on explaining the safety behind the hydrogen, making sure that doesn't off gas, whatnot, everything. Understandably, you guys still use a battery pack, and I assume it's a lithium battery pack. Is there any protocols put in place to stop a hypothetical fire? We know that lithium fires are extremely intensive, really hard to put out. But on top of that, these are consumables. They have a lifespan, they die. How are you guys disposing of the batteries and these tanks?
Excellent question. First one is about battery safety. So this comes back to system level design. There's a reason why we package the battery in that center line where we package it. I mentioned also that we have a system of pyrofuses that allows us, if anything is compromised, we essentially fire those pyrofuses, and with that open the contactors permanently of the battery pack, which is pretty much as safe as you can get. You still have, depending on your state of charge, the chemical energy in there, right? And you can't really get rid of that. And that's where you come down to the component level design, right? Where it comes back to the battery level design. There are scenarios where you can't prevent an impact, for example, to the battery and a subsequent thermal runaway to some extent. But that's really component level design to keep that contained. And there's big differences in the component level design on how quickly that can progress. The other question about recycling, absolutely. All of our battery packs, for example, that we used in previous development for vehicles, development vehicles that we're scrapping now, they all go through a recycling process. So we work with the well-known players in this space. We have collaboration and contacts with them to do battery recycling.
Thank you.
Are the trucks you're building today compatible with the SAE 601-5, the higher flow fueling protocols, or is that, because the stations aren't supporting that yet, right?
Excellent question. Yes, we were part of that whole working group, and we have that implemented in that capability already on the truck side, and we have implemented that pretty much already on our fueling assets too. And that's part of getting to, by the way, the fueling time that I was talking about. If you wouldn't use those new tables and kind of pushing that notch, then we would not quite get to the 20 minutes refueling time.
That's what I was going to ask. I was going to ask how much faster it would be with the new, but you've already baked it into the number.
Yeah. I mean, it all comes back at this point. It comes back to the dispenser, right? The dispenser needs to be capable of that flow. And with some of those assets, we are capable Some other ones are a little bit more limited, so the refueling time is maybe a little bit higher. And then ultimately what we're doing is we started an industry consortium with Toyota, Hyundai, Shell and others to develop fast fueling, so the H70HF protocol, or I should say the hardware for that. And that hardware is in prototype stage right now. The target of that group is to establish 100 kilograms fill in 10 minutes. So you're pretty much looking at 10 kilograms per minute fuel rate average. And for that we need the new hardware, which we're working in the industry group. And then we obviously have standardization efforts to look at the communication protocols and mechanisms, because you're probably not going to rely on unidirectional, IRDA kind of type communication. Plus also then the actual fueling protocol design. So that one is a bit more in the future. That's why I didn't want to talk about that. That's not something we have in production. But what you see here is already baked in pretty much the Dash 5.
I have two questions. One about the cab over design. So you mentioned it's basically based on the needs of European. I used to work for Freightliner, so I saw the demise of cab over. What comes to mind though is crash worthiness. That was always a concern we had there. So how have you addressed that? And then the second is in North America, especially long haul, there's quite a need for dual axle drive. And so what you presented was a single axle. So what is there future plans for derivative and a dual axle with the interlock system?
Right. Great questions. Cab over design. If you look at the US market and the cab over designs that were present, years and years ago, they really don't compare to what you see, for example, today in Europe in terms of the design and technology. So, and one of the reasons of lots of complaints was, yes, crash worthiness. It was also sitting on top of the engine, and those engines weren't very great. So there's lots of concerns about that and comfort. If you go into our truck and you drive it, the comfort level is, much better than any diesel, conventional design you would have. So I think some of these concerns, just going to the new technology of a fuel cell or battery electric truck, they just go away. And then some of the disadvantages back then, as you think about the cab design and the structure and so on, they really are no longer as relevant. These cab over trucks, they're designed, if you look at the design for crash, and again, we did all of the crash testing, including frontal crash. And I would stack that performance specifically on crash up against any conventional truck. It really comes back on how you design the structure, how you absorb some of the crash energy. So I think we might, and we're not the only ones, by the way, I think you might see a little bit more cab overs again going forward in the US, at least for day cabs. Now, if you think about long haul and sleeper, obviously in the US you have all of these big condo cabs, and what we have actually here as a day cab is in Europe a sleeper cab. That's as big as it gets based on the regulation, right, and the limits. And I think that the drivers won't give up. So they will still want to see more like these condo cab, bigger designs for sleeper trucks. And you're absolutely right, 6x4 architectures. Also, if you think about certain places in Canada, it's actually mandated in some of the provinces there to have a 6x4 architecture. So, can't give you all the specifics, but we're working on solutions there in the relatively near term. So. Oh, I got a little.
Can you speak more about the high-level capabilities of the deployable hydrogen stations? You said those can be deployed in 8 to 13 weeks compared to the hydrogen stations.
Yep.
So what applications would those be for? Would those just be for fueling the hydrogen trailers, or would it be for actual deployment?
Yeah. Yeah. So pretty much a setup of these trailers, once we've built and tested them, is very, very quick. We're really talking a day or maybe 2. What still takes time is the permitting process. You still need permits to put one of these mobile assets or modular assets down on the ground. You know, you need the fire marshal to come out and give his okay and everything. And so that's very different from like city to city. It's not even county, it's not state, it's city to city, fire department to fire department, building department to building department. And that's been challenging at times, so that's where really the time comes in, is for the permitting. And yes, we use those then to fuel trucks. So think about, we have a new fleet that wants to operate out of Stockton, right? And we had that on the map. Now we start maybe with 10 trucks there, 20 trucks. It's really hard to make a business case and justify a multi-million-dollar investment for a permanent station. So we start deploying these assets, we build the demand, maybe we get another fleet in and another fleet in, and maybe at one point we're at 50 trucks to 100 trucks. Then at that point, it's much easier, whether that's us or a partner, to do the investment for a permanent station. And so it's more or less a temporary solution, but temporary can mean, 2 years or something. And then we come in with liquid hydrogen trailers, and we essentially replenish the hydrogen of those fuelers. Just like you would do in a gas station today, when the tankers come in and pretty much replenish the on-site tanks.
I have a question about fuel cell.
Yep.
Battery technology is becoming more commonplace, the reliability is going up. The fuel cell is probably the newest technology in your system. Could you speak to that and maybe give us an idea about maintenance and life, and expected life of the
Sure. Yep. I would say fuel cell technology in itself is actually not that new, but it is, if you talk about industrialization, getting to kind of the scale, the volumes, and then in this application, absolutely. And yes, that's an area we continue to work on. We've been working here for our first generation of truck and fuel cell together with Robert Bosch. It's my former employer. We continue to work with them to optimize. We've designed it initially for 15,000 hours life at least. We want to get ultimately more out of it. And we're still in the proof out of this. So I had this conversation earlier tonight, and I always say, the proof is in the pudding. You can't claim you reach that without having trucks out there that actually reach it. Now, we did lots of accelerated, aging testing and durability testing on test benches, component level, system level, but ultimately we need to prove it out in the truck, in the applications. And I don't have a single truck unit today that has 1 million miles or something. So, that's still to come. But those were our targets. We've seen good results in the component level testing and system level testing. And as I mentioned earlier, there's also good lever in kind of the overall system operation, what we call the energy management, balancing loads and load dynamic between the fuel cell and the battery pack.
What's the long-term business strategy given how limited the company is with infrastructure?
So first of all, we want to push both applications forward, right? Battery electric and fuel cell electric. Sometimes it's too much of a debate of an either or, and we say it's and not or, right? And for the battery truck, we rely much more on other players or existing infrastructure. So we're not as involved there. We're obviously helping the fleets, and we had a similar approach with kind of those mobile assets. But there's a lot of players out there already. One of our customers, Watt EV, they build out charging parks specifically for trucks. And those are kind of partners we work with and on the battery electric charging infrastructure. And then on the fuel cell and hydrogen infrastructure, as I mentioned, we're trying to do it in steps, and we're trying to scale both sides equally. And you can imagine, I mentioned a permanent station, and the cost of it is, multiple times as much as one of those modular units. So those modular units, they're just a much more digestible investment. And so we can, as I said, build this density, build the demand, and then have a much better case of potentially having partners kind of in. We won't do it by ourselves. We won't do it by ourselves, the infrastructure build out. We are relying on a network of partners on that.
Just one curiosity or anything. Considering federal weight limits, is there a significant difference between a diesel truck or a battery truck? Like, let's say if a company wants to transport produce, will they have to transport less produce using a Nikola truck compared to a diesel one?
Yeah, another excellent question. You have all the right questions tonight. Today, the tractors are heavier, first of all. There is an exemption for another 2,000 pounds. So from the 80,000 federal limit to 82,000. That's currently federal for battery electric, not yet for fuel cell. Don't ask me why. But it's on a state basis, it's also available for fuel cell trucks. So for example, California, Arizona, and a few other states give you that exemption too. So that 2,000 pounds helps making up for the delta. We did choose the route for the first development here of robustness, meaning that there are some systems that you could argue are maybe a little bit over-designed from a structural point of view. And so as we go forward, we will work on getting the weight specifically down. Today, we're still at a disadvantage. So yes, if you're weighing out in your application today, you'll be impacted. You will be able to transport maybe a pallet or two less. Many applications, though, cube out, right? And that's where it's really not relevant. And going forward, we want to capture most of the market, and we don't want to be limited, right? And maybe miss out on 10-15% of the market of the ones that weigh out. So that's going to be an ongoing process to get the weight down. And again, the target is to get as close as possible to diesel. Today, we're a little bit away from it. So our fuel cell truck is about 26,000 pounds. A diesel truck, depending on how you spec it, if you go completely bare bones, you can spec it down to 15.5 maybe. Maybe on average it's more like 18,000, so then account for the weight exemption, we're still falling a little short.
I have a question. You mentioned earlier working with FEF and Shell for hub-and-spoke applications on short, medium hauls. Are you guys working with Air Liquide and Plug Powers on long-term solutions for getting the kilogram per mile cost down for distributing?
Yeah. We are working with, or I should say, we are trying to work with pretty much everyone you could think of and mentioned already in that space. So question was about, are we working with Air Liquide or Plug or, Power and so on? And we've announced in the past, for example, a collaboration with Plug Power. Obviously, all of these players are watching closely what we're doing, and we've been getting more and more calls as we push out more and more trucks. So I can confidently say that all of these players in this space are very interested to see what we're doing here to scale this industry, and are very open to partner up with us. May that be on the production, on the distribution, on the dispensing, all of these areas.
I had a question about cost parity, the fuel cost, the hydrogen versus the diesel, and the purchase cost, because I imagine those are both separate.
Yep.
I apologize if you covered it. I missed it.
I did talk a little bit about hydrogen costs, but happy to go into this again. This industry looks at total cost of ownership, right? So it also includes maintenance cost and so on. On maintenance is where we think, and from what we see so far, we should have an advantage towards diesel. On the purchase cost of the truck or the lease cost, we have a disadvantage. That's where the incentives come in. With incentives, depending on your fleet size and where you buy and so on, you could actually get the truck cheaper than a diesel truck, but it really relies on incentives today. Without incentives, we're looking at maybe factor 2.5 or so more expensive if you can't get any incentives. And that wouldn't then also not even account for the 40,000 tax break out of the IRA for every zero emission truck. And then on the fueling side, if you talk about parity, I mentioned our fuel economy, right, on average 7.2 miles per kilogram. We see also fuel economies up more towards 8.5. And if you compare, what does that mean in terms of miles per gallon, right? A kilogram of hydrogen has about 33 kilowatt hours of energy, diesel about 37 or so. So it's a bit, it's to somewhat comparable, a gallon of diesel and a kilogram of hydrogen. And so as we equate those numbers, you can say we're more efficient by about 20%, and then that's about what you could charge more if you just compare fuel on an equal to equal basis, a gallon of diesel versus a kilogram of hydrogen. So depending on what you buy your diesel for, maybe fleets in California pay around $4 or so, maybe a little bit more. That would equate to a parity price of hydrogen of around maybe $5.50 per kilogram of hydrogen. And that's what we're pushing towards. Not quite there, but we're working with our fleets to make sure we're getting to as close as possible to parity.
What is the current cost for truck customers for hydrogen?
Yeah, that's where I said, if you go to the pump today in California, you'll see prices sometimes north of $30 per kilogram. That's not what our customers are paying because we have partnerships and we're sourcing the hydrogen fuel. But all of these agreements are individual agreements with the fleets depending on their application, how many trucks they buy and so on. So I can't really give you a number there. It does vary from application to application. It's much less than the 30 for sure.
Yeah, I just didn't know if you could give us a ballpark. Are you halfway to diesel or?
Yeah. Yeah, but the ballpark you mentioned is not off.
What is our production, estimate production for the hydrogen versus battery? How many are you going to build?
So right now we're, based on the demand and based on the fact that we're still going through our recall operation for battery electric trucks to get those back into the field. Our new production at the moment is entirely fuel cell electric trucks. So, and we've, you can read up on kind of the numbers we delivered to the market. We pretty much sold every truck that we could build so far. You can imagine ramping up this new technology. There's growing pains also with the suppliers. At times you can be limited there. And not only the new technology components, but even other commodities that you would think, hey, that should be easy to source. There's always disruptions happening. So,
thank you.
What's your fuel to electrical efficiency for the hydrogen fuel cell, including, the compressor and all the ancillaries you have to run?
Yeah, good question. So the fuel cell system, so we always look at system efficiency. So accounting for the compressor, you need to run all of these auxiliaries, the balance of plant as we call it. I always want to quote a cycle efficiency, because I don't care what your peak number is if you're never going to reach it, right? So in a typical cycle of a Class A truck, and based on the design that we have, we're talking at about 50, 51, 52% net, so system level efficiency. That means from the hydrogen to electric power available for the truck to move the truck.
At the wheels?
Not at the wheels. You still have the efficiency of the inverter and the motor. Inverters maybe 98, 97, 98%. We're using SiC inverters, so fairly high efficiency. Motors, depending on where you run, but north of 93, 94% most of the time. So you got to subtract that too. But if you want to compare it also to battery electric, right? It's kind of what I quoted in the cycle efficiency gets you what the electric power is available for the truck. Okay, maybe last question? Maybe last two? Okay, we have two, yep.
BOM or the parts cost of the hydrogen truck, what is the most expensive part of that?
Fuel cell system, closely followed by tanks, as expected, because we haven't really started scaling there, right? So that's an area where we continue to work with our suppliers to get the costs down. But there's very, I would say, low-hanging fruit that are just, starting production for the first time and then just scaling to more sustainable levels. Just with the economies of scale, there's pretty low-hanging fruit to get that down. But right now, that's the highest cost portions.
Does the recent commercialization of fuel cell stacks, does that help reduce your costs, or is that?
Obviously it helps. If the industry overall scales, and if you go to even material levels or subcomponents and so on, it helps. At the same time, if you look at some of the other applications, it's not like you can necessarily use the same stacks, for example, or the same compressors. So if you scale a production line to do forklift fuel cell systems and the balance of plant for it, it doesn't necessarily help the kind of system designs and levels that we use here, right? So that comes with being first, with pioneering, with pushing the limit. You're the first, so you have to be the one who actually pushes and scales it up. So I think we're gonna do last question here. Yeah.
On a long downhill grade, how is the speed controlled in the battery truck, and how is it controlled in the fuel cell truck?
Good question.
Great question. Probably thinking we're missing an engine brake, right? A retarder. I'm not sure how familiar you are with Class 8 trucks, but if you're driving down, for example, Flagstaff to Phoenix, and you're using your air brake system constantly, you're gonna overheat the brakes in no time. So we do need an engine brake replacement, and obviously that's regenerative braking. And you hit it, on the nail on the head already. The difference between the fuel cell truck and the battery truck. The battery truck has a much larger battery, which also means that the power capability is much higher. Just based on equal to equal C rates, higher energy means much higher power. And so our battery truck has absolutely no issue with that. Meaning that even with higher levels of state of charge, we actually reserve a little bit that we allow to go over in case of regenerative braking. You can pretty much just cruise down the hill with a adaptive cruise control setting, and it will just utilize your electric motors and regenerate the electric energy and put it back in the battery. And it's actually a substantial amount of energy you can recoup in a route like Flagstaff to Phoenix. I mean, you're talking about more than 50 kilowatt hours, right? So a lot of power, a lot of energy, sorry. For the fuel cell truck, we're a bit more limited in the power capability of the battery, so it's a bit more of a balance. So we also utilize a brake resistor just to ensure that under all conditions we have sufficient brake power available. And then the same concept, we utilize the regenerative braking system as a replacement for the engine brake. And then the same thing, you would set your cruise control ideally, and you would just drive downhill. Obviously, we still have a very capable air brake system, and if you have to do brake actuations because you're going to a higher speed, or you have someone in front of you, traffic or whatever, that's still available. But the basic principle is similar to an engine brake today, and replacing that by regenerative braking. Very good question. All great questions. So I think with that, thank you for the great discussion.